problem number 3.4. The question is, calculate the magnetic flux coming out of the surface which is containing the magnetic dipole as shown in the figure. Okay, so we have to find what? We have to find with the magnetic flux. So consider with this diagram. So in this diagram we are having a magnet which is enclosed in a surface. Okay, so whenever we have a closed surface, we can always say that the flux inside the closed surface is equal to 0. So this is a main concept which you have to know, because we are considering a closed surface. So whenever you are considering a closed surface, the flux inside any closed surface is equal to 0. Okay, so using this we are going to find the value here. Okay, so the formula is written as phi is equal to integral of B dot dA. Here the magnetic dipole is kept, the total flux which is from the closed surface. So whenever you are considering a closed surface, the flux is equal to what? 0. And so we are writing that flux will be equal to 0 here. Okay, since the flux is 0, this integration is also equal to 0. So we are just writing that integral of B dot dA which is equal to 0. Okay, and hence here the integral is taken over the closed surface. So we are taking the integral for a closed surface, since no isolated magnetic pole exists, because always a magnet will have a dipole, because it has with a south pole as well as a north pole, is it not? So we can say that there is no isolated magnetic pole, or a monopole irukadu, adanal and the integral is also becoming 0. So this integral value is equal to 0. Okay, so clear?